on sodium ions and chloride ions, but whereas the charge on magnesium ion and oxide ion is twice the charge on sodium ions and chloride ions. Hence, the force of attraction holding these two ions together is almost double, exactly double actually, is stronger than the force of attraction holding sodium ions and chloride ions together. The electrostatic force of attraction again is stronger in magnesium oxide because the charges on magnesium ion and oxide ions are stronger than the charges on sodium ions and chloride ions. Therefore, more energy is required to overcome the force of attraction, hence relatively higher, much higher melting points and boiling points. Then ionic compounds conduct electricity when they are dissolved in water and when they are in molten state. But they do not conduct electricity when they are in solid state. You see, when they are in aqueous state, like for example in dissolved in water, or in molten state, the ions are free to move and hence they can conduct electricity. In solid state, the ions are held in fixed position in the lattice structure, therefore they cannot conduct electricity. Let's look at it again. Ionic compound, any ionic compound, they conduct electricity. Question is, why do they conduct electricity? When do they conduct electricity? If they do conduct electricity, why? And if they don't, again, why they don't? What is the basic reason that ionic compounds are able to conduct electricity? When ionic compounds are dissolved in water in aqueous form, let's say sodium chloride aqueous solution, right? Or they are in molten form, say sodium chloride in molten form, NaCl in molten form. So what happens is that the ions, the positive and the negative ions present in the aqueous form or in the molten form are able to move. The ions are able to move from one place to another, like they are moving from here to there. So if they are able to move from one place to another, they are able to conduct electricity. The same happens in aqueous form, the same happens in molten form. But in solid form, the ions are not able to move. When an ionic compound is in, say, solid form, ions cannot move. They are held in fixed position. They cannot move from here to there. They cannot change direction. They cannot go from one place to another place. And it is due to the free movement of these ions that ionic compounds are able to conduct electricity. If they are still, if they cannot move, then they cannot conduct electricity. Okay.